है आपका बायजूस एग्जाम प्रेप सिविल मैकेनिकल एंड एक्जी चैनल पर. I hope you all are doing super fine. So in today's session, we are going to talk about the MSQ of fluid mechanics and open channel flow. And this entire session is going to be in English language only. So quickly, please tell me everyone if I'm audible and perfectly visible, and then we will begin this session with full power. And you can share this beautiful and also very important session with your friends so that everyone can get the information and all the questions that I'm going to talk about in today's class. All right guys, so quickly tell me who all are here in the chat section and watching me live, and also kindly just verify about the audio and the video of the session. Okay, a quick introduction for all those who are watching me for the very first time. My name is Joshit Singh and I have 4 years of teaching experience now. I'm Tech from IIT Roorkee. Specialization of MTech is in hydraulic engineering. A GATE 2017 top up, produced 20 plus top rankers under AIR 100 in ESE and GATE. And my area of expertise specifically are transportation engineering, fluid mechanics, irrigation engineering, and environmental engineering. But this session is all about the fluid mechanics and open channel flow. Before I begin, if you are interested in getting 90% scholarship in our classroom program, then there is a scholarship test planned for you by BYJU'S Exam Prep on 26th November, 8 p.m. only on BYJU'S Exam Prep application and also the website. Okay, so you can get into this and you can avail 90% up to 90% scholarship in our classroom program. Next, another thing very beautiful, very innovative that we are bringing on this YouTube channel as a free content, and that is going to be a daily dose. Daily dose you are going to get every morning from both the branches, civil and mechanical engineering, in which you may get a question of the day or you may get a concept of the day. It is completely independent. It is completely, you can say, depend on the faculty member what they are going to give. Hi Arun, good evening, welcome to the session. Till then, like I'm explaining all these things, can you please share this session with your friends so that more people can join? Hi Yamini, how are you? Good evening, welcome to the class. And guys, I'm clearing this one more time that this session is going to be in English language only. Alright guys, so please keep sharing this session with your friends and let them know if in case they are not joining because they think that we are only taking the session in English, Hindi. No, this is not Hindi, right? This is English only. Good evening, Purva, Dinesh, good evening. Hi, Rishabh. Oh, Rishabh Pant is here. Superb. Amazing. Okay, so the timing, I would say I'll take only 40 to 45 minutes. That's, I think, the average time which I take in every classes, right? Apart from this, if you want the free ebook, then you can just download them from the description box. It is available. Oh my God, I have the very first question. Okay, so I hope you all are super ready. I have marked the question number. So whatever answer you would like to get me, just tell me the number and tell me the answer of that number. Acha, daily dose, I think it is in the morning only, 11 and 11:30, I suppose. 11 and 11. That will be a video, very short video. It will be of, I think, 5 minutes to 10 minutes range. Right, so that is going to be very beautiful. Like for example, if you want, I'll tell you some of the topics which I'm going to tell you. One topic which I'm going to tell you quickly, I will tell you in one video in just maybe 5 or 6 minutes, that what is the basic difference between the theoretical Kant and the actual Kant. Lot of students get confused over there, and how you can calculate them, and actually why it doesn't matter now that what is actual Kant and what is theoretical Kant after there are a lot of modifications that are being done by Indian Railway. So now we are not at all interested in the actual Kant or the theoretical Kant, but still I'll tell you that what was the concept and today what we are going to follow. So I am ready with the very first question in this session of MSQ from fluid mechanics and open channel flow. If you are also ready to answer, can I get a quick heart sign in the comment box please, and then I'll show you the very first question. I suppose I'll be having 15 questions, I don't remember, but yeah, more than 10 I remember. Quickly just send me a heart sign if you are all super power ready. I have the very first question exactly like ready. After this slide I have the very first question. Alright, I suppose we all are ready. So here is the very first question of my class. So guys, please try to answer. Obviously this session is MSQ session, so every question here is MSQ. You will be getting no negative marking of MSQ, so please try to answer. Which of the following are the method of dimensional analysis Reynolds method, matrix tensor method, Rayleigh's method, or Bridgman's method. Out of these 4 methods, which of them are the method of dimensional analysis that we actually follow? Quick answer, guys. This is let me tell you guys again one more time. This is basically an MSQ session. This is a MSQ session. So maybe it is not obviously every time true that you will be having more than one answer correct. There is a possibility, because in the brochure they have mentioned one or more than one option may be correct, right? So they have never said 2 or maybe more than 2 will be correct. So there is a chance. I don't know, till now we did not get any previous year in which there is only one correct option of MSQ, but by the language we can actually say that yeah, it can happen. Hanji sir, quickly answer everybody. Full power. So Reynolds, matrix tensor, Bridgman, Rayleigh's, or the Bridgman. Everybody will answer. Okay then, no problem. I'll make this easy for you, right? Okay, so the very first method is Reynolds method. Guys, Reynolds method is not a method of dimensional analysis. So very first option is obviously wrong here. Then matrix tensor method is correct. Then Rayleigh's method is also correct, and Bridgman's method is also correct. Apart from that, there is this Rayleigh's method is done. Buckingham pi. Buckingham pi is also there. Buckingham's N method. We study also in fluid mechanics. Yes or no? Rayleigh we study, Buckingham pi we study, in which we understand the pi terms, number of pi terms, m minus n that we do, right? Apart from that, Reynolds method is not a method of dimensional analysis. Please remember this. And apart from this, there is something called you can also do by visual inspection. That is also a method. It can be done with the visual inspection as well. And rearrangement of differential equations. These are few methods for the dimensional analysis. Please remember them. These 1, 2, 3, and apart from this, there is one more, that is Buckingham pi and visual inspection, and also rearrangement of the differential equation. Those are the method of dimensional analysis, not the Reynolds method. So the right answer here is going to be B, C, and option D. So 3 statements were right here. Next question is here in front of you, and I suppose each and every one of you can answer this question. Which of the following statement is or are correct? Vapor pressure increases on increasing the temperature. Boiling point is more for a liquid which has less vapor pressure. A more volatile liquid will have less vapor pressure relatively. Cavitation can be prevented by maintaining large pressure in the flow. Again, MSQ question. So maybe more than one or one option is going to be correct. So please try to answer this right away. Come on. Aja, before I answer this question, can I ask you a side question related to this concept only? Can anyone tell me what is the boiling temperature or boiling point of water? Can anyone please share the boiling point of water? It's just a normal water, nothing else, like a normal impure water, you can say. What is the boiling point of a water? Of water, not of a water. Okay, Raghu has given the answer, and Wali is saying 100 degrees Celsius. Arun is saying C2. Okay. Yamini is saying 100 degrees. Dinesh is also saying 100 degrees. All right. I can see a lot of you know the answer, right? A lot of you know the answer. Priyanshu, 100 degrees Celsius. Again, very good. Okay, one thing I would like to say that I have to appreciate, and that is that you have the habit of writing the unit also. That is the most, you can say, beautiful thing that you can do while preparing for GATE examination. It is going to save a lot of marks in the examination, you will see. Right, so that is good. But the sad part is, or the bad part is, that the answer is wrong. Right, boiling point of water is 100 degrees Celsius at atmospheric pressure. Right, remember this one thing, at atmospheric pressure. Suppose if I have this water bottle, and right now I can start boiling it without even increasing the temperature. How I can do that? I can simply do that if I decrease the pressure around it. Right, suppose if I just put a tube inside this and I just do the airtight, I just airtight the cap, and then I start decreasing the pressure inside the bottle. So what will happen is the pressure will slowly come down, and the point at which the pressure will reach equal to the vapor pressure of this water, the water will start boiling. All right, even on this room temperature, which is somewhere around, I think, 28 degree or 27 degree. Right, sir? So it is actually pressure dependent. Remember one thing. So coming back to the question, vapor pressure actually increases or increasing the temperature. That is definitely right. Then comes the boiling point is more for a liquid which has less vapor pressure. I think just now I have proved it. After that, a more volatile liquid will have less vapor pressure. Actually, it will have more vapor pressure, not less, because it is volatile in liquid, volatile in nature. Cavitation can be prevented. Now, what is cavitation? Basically, what happens, as just now I have given you one example, that how by decreasing the pressure, I can boil the water. Now, suppose if I have a penstoke, or maybe I have a pipe, and in that pipe, somehow the pressure starts decreasing. And if the pressure will start decreasing inside the pipe, then what will happen? There will be a point at which the vapor pressure and the pressure inside the water pipe is going to become equal. And as soon as that event will happen, the boiling will start. And when the boiling will start, the bubbles will form. And those bubbles will comprise of steam. Steam is more dangerous than fire. If you don't know, I'm telling you. Steam is more dangerous than fire. Those who work in kitchen, they know better. Like maybe your mother, maybe your father, maybe your cook, whoever is working in the kitchen, they know this very better. Right? I have also experienced this personally. Right? Now those bubbles, they simply go and collide with the boundary of the pipe. And eventually what happens, that they bombard on the inner side of the pipe, and slowly what happens, cavity starts forming on the inside of the pipe, and that causes the cavity inside the pipe, and that process, whole phenomena, is actually called as cavitation. All right, guys. So that is the thing. So cavitation, basically I have got this, that if I have to, very good Arun, if I have to prevent cavitation, I have to make sure my pressure is larger. So larger pressure in the flow will definitely prevent the cavitation. So for this particular question, option A, option B and option D are perfectly correct option. Guys, I hope you are learning. I am trying to give you more than what I have here as the question. All right. And I'll keep on doing that, right? Moving on to the next question, which is the question number 3. Okay, here's the question. I think this is something that you have done if you are done with the open channel flow. For the derivation of differential equation for water surface profile in open channel flow, the equation used is, remember, nobody is going to ask you the derivation. Nobody, right? Very rarely there will be some derivational changes that they may do in the examination, and on the basis of that they may ask you the question, but here they're not asking you the derivation. But to answer this question, you should know the derivation. You should have done it at least once, then you can answer this question. So which equation is going to be useful? Energy equation, momentum equation, continuity equation, moment of momentum equation. Quickly answer, everybody. Let's see who will get this answer. Quick. Come on, answer. Guys, just you can, if you want, you can just use the logic and then try to answer these questions. Okay, Achu has given the answer, Arun has given the answer, Raghu has given the answer, Karthikeya has given the answer, Karthikeya. Okay, what else? Who else will give the answer quickly? Alok. All right, ABC means energy, momentum and continuity. Guys, always try to understand the question and always try to comprehend the options that you are getting here, right? So quickly please try to answer. All right, so please understand here, basically when we are dealing with the open channel flow, and if I have to make the water surface profile, then two things I need to conserve: energy and mass. Now who among this will conserve the energy? Obviously the energy equation or the Bernoulli's equation. The second name is Bernoulli's equation basically. And out of these three, who is going to conserve the mass over here, everyone? Is it momentum, continuity, or the moment of momentum equation? That is going to be the continuity equation, because that is the one who is conserving the mass. So this actually conserves the energy. This actually tells us the energy is conserved, and this basically tells us that the mass is conserved. So out of these four, I think option A and option C are perfectly right for this particular question number 3. Okay, so quickly, quick feedback I want. Shall I increase the speed of like solving the question, or the speed is okay, or should I slow down? Please, you are the, I can say guide. You can guide me if I have to increase the speed. Speed is okay, or you want me to just slow it down. Everyone, increase. All right. Okay, okay. Most of you are saying okay. Arun is saying increase. All right, no problem. All right, let's do one thing. If there is something conceptual, if there is something, I would say theoretical, I will quickly give you my explanation and then quickly just to go through that question. If there is something numerical, then I will explain it step by step. There, I will not make any hurry. Cool? I hope I am able to make happy every student. That is actually not possible. Yeah, for a given discharge in a horizontal frictionless channel, two depths corresponding to same momentum flux are known as. Now, this is actually in the slide because this is something which make, you can say, a lot of confusions among the students and among you. Right, so that is why I want you to just see them once and for all and never forget this particular thing. Now, quickly please answer the alternate depth, the conjugate depth, or the sequent depth, or the critical depth. Everybody will answer this question. Everyone. Come on, guys. Is this alternate? Remember, guys, they are talking about the momentum flux. Momentum flux, not the specific energy. Not the specific energy. They are talking about specific force. Is it sequent depth or what? Momentum flux, specific force is going to be same, or you can say when there is a hydraulic jump, that time also you see specific force is same. Yes, very good, Kartikai. Now this is basically MSQ. So who is the other brother of sequent depth? If you know that sequent depth is right. See, we all know that alternate depth is definitely not the right answer, and critical depth is also not the right answer. Now the option remain B and C. You know, okay, sequent depth is the one of the answer, or maybe only answer. But what about the option B? Can I call the sequent depth as the conjugate depth? Can we call it? Tell me, please. Can I call a sequent depth as a conjugate depth also? Come on, Akshita, Achu, Priyanshu, Arun, Raghu, I want answer. Quick, tell me. What is actually the conjugate depth? If not, Rishabh. If not, then what actually is conjugate depth? Come on, everyone. I'll quickly share the session also with everyone. Those who have missed it, I suppose no one should miss the session because... All right. Done. Both are same. Definitely. They both are same. So here option B and option C are definitely right. So this is question number 4. B and the option C are definitely correct. They both are same. Moving on to the next question. And I think we have the very first numerical here. Come on, everyone. Let's see. 1 to 6 scale model of a passenger car is tested in a wind tunnel. Okay, just watch closely. The prototype velocity is 60 km per hour. Model drag, okay, model drag is 250 Newton. The air in the model and the prototype can be assumed to have same property. Which of the following statement are true? Drag force of the prototype. So I would say I want the value of Fp. What else? Power required to overcome the drag in the prototype. So we can say power required in the prototype. Very good. What else? The drag force on the prototype and the power required. So these two things are required, Fp and Pp. So basically what is given to us? The prototype velocity is given, which is 60 kilometer per hour. Velocity of prototype is given as 60 kilometer per hour. Very good, super, amazing. What else is given to me? The model drag is given. So model drag is given to me as how much? This is for model, right? That is given to us as 250 Newton. All right then. Quickly guys, can you please tell me which dimensionless number I should use over here? Which dimensionless number I should use over here in this particular question? If you know that, then question is super easy for you. You can do it very, very easily. Come on, answer, answer, answer here. LP by LM is given to you as 6. Or you can say LM by LP is given to you by 1 by Mac. कैसे आ सकता है? How can Mac come here? You can actually use the Reynolds number can be used easily. Froude, this is not where the gravity forces are predominant. This is not where the gravity forces are predominant. If gravity forces are predominant, then you can say Froude's number. Right. So basically the concept that we are going to use over here is the Reynolds number of the model will be equals to Reynolds number of the prototype. In general, what is the Reynolds number? Rho V L by mu. So you can say rho R L R V R by mu R should be equals to 1. That is what we have learned in our model and dimensional analysis, right? So from here, if anybody would like to try the answer, see, they have said that the model, the air in the model and the prototype can assume to have the same properties. So out of these, which of them are the property of the fluid? Can I say rho R and mu R? So obviously the density scale ratio and dynamic viscosity scale ratio is nothing but it is equals to 1 only. I hope this is very clear to you why it is 1, right? You are left with LR VR equals to 1. So you can say that it is equals to how much? LR VR equals to 1. Now from here you can find out the value. Quickly please try to answer. Everyone, I am waiting. 21 minutes are already gone. So we'll like there are some questions which will take time. There are some questions which will be solved very easily. So do not worry about that, right? So please try to answer. So let me just do it for you. If that's the case, I'll quickly solve this for you. I'll try to utilize this space. So LM by LP into VM by VP equals to 1. I have the ratio of LP by LM 1 by 6 and I have the value of VP. From here I can get the value of VM. So can anybody give me the value of VM, please, everyone? Anyone? Because see, LP by LM is 6 here, 6, and VP is how much? 60 kilometer per hour. So I'll just convert this in meter per second. So 0.278 into 60. I suppose we are done with this, right? So what is the velocity here of model? In meter per second you will get. Guys, can you quickly see and tell me? Aerodynamic test, but rocket, the velocity is completely like this velocity is how much? The 60 kilometer per hour. 1 Mach is too much. So obviously here you cannot use Mach. Right? Hanji, how much is this? I think it should be 100 meter per second. Is it true? Like, is it correct? Just please solve this and tell me. Thank you, Alok. And now I know that the drag force and the prototype, if I have their ratio, then also I can solve this. So I know FM by FP, drag force on model by drag force on prototype will be equals to rho L square VR square. So rho LR square VR square. So I know length scale ratio, I know this ratio, and I also know the density scale ratio, which is 1 only. I know FM, I can get the value of FP. Can anyone quickly get me the value of FP? FM is 250, this is 1, this is 1 by 6, so 1 by 36, and this I can now find out as 60 by, or just convert this and get me the answer. Fatafat. Okay, I'll side. You can take the screenshot or anything if you want, but later. But first, please the answer. It's 2. How much it is? 100 we are getting. 5 by 18. 1 by 36. 6. I think it will be same only, kya? Quick, everyone. Just please check with the calculation, but as per my calculation, it should be 250 Newton. You just check it with your calculation once. So if that's 250 Newton, so I suppose option A is correct, but I need to get the value of power required. Power required is going to be the drag force into the velocity for prototype. So power is going to be 250 into how much is the velocity of the prototype that we have got? We have got is that it is given to us 60 only, right? So 60 into 0.278 divided by 1000, so that we can get the answer in terms of kilowatt. If you solve this, the answer is let me tell you, 4.167. But kilowatt. So I think option B is right here, right? So A and B, these two options are definitely correct for this numerical answer. Very good, Alok. And I also suggest everyone to please solve such questions. It is very important for you. Okay, there is another thing that I need to tell you is that we also have another series which is going on already. It is concept capsule for GATE and ESE. Here we give you the concepts in Hindi language, and this is the schedule of it. Till now we have given you the fluid under acceleration, shape factor in plastic analysis, BOD all cases, all about strain rosette we have given, flow profile I have taken, spacing of stirrup Satyajit sir has taken I think yesterday only, then phi index, W index, Richard will give you, and these are the upcoming topics from this particular series. Moving on to the 6th question. Which of the following are dimensionless quantity? Quick everyone, फटाफट आंसर आएगा इसका. Let me know. Guys, you obviously know what is the unit of hydraulic mean depth. Okay, you already know kinematic viscosity. Even there is a question also that they have asked. So option A and option B are the right answer. Mach number and skin friction coefficient, they are the one which are having no dimension. They are the dimensionless number. Next is the pressure outside the droplet of diameter 0.05 mm is 100 kilopascal. If surface tension of droplet fluid is 0.05 Newton per meter, which of the following is true? Alright, the pressure outside the droplet, pressure outside the droplet is 100 kilopascal. My goodness. Right, and we know that pressure inside is actually equals to the axis pressure plus the outside pressure. Always remember, inside pressure is always more. Right, surface tension is also given to me, and it is given to us as 0.05 Newton per meter. What else is given? I think diameter is given to us, so D is given to me as 0.05 mm. Right, now what I need is the pressure inside the droplet is 95 kilopascal if the droplet is water bubble and if it is soap bubble. I have two cases. Droplet is soap bubble, droplet is water bubble. So what are the conditions for soap bubble and the other case, that is the water bubble? They should have said water droplet and they should have said soap bubble, because that is the right word to use here. Come on guys, anyone? So when I talk about the water droplet, it is how much? 4 sigma by D, right? The axis pressure here is 4 sigma by D. Whereas this is for, I will write droplet only. This actually means when outside and inside medium is different. When there is a droplet, outside medium is air, inside medium is water. But same axis pressure can also be seen if outside is water, inside is air, which may happen when you go inside the swimming pool and you make bubbles. That is the same thing. And for the soap bubble, it will be double because we have 2 layers. So 8 sigma by D. This is for the soap bubble. You guys are super intelligent. So I'm guessing you can quickly answer to this beautiful question. Come on, everyone. I have given you, I think, everything. You all need is the PI. The inside pressure is required. PE and PO. you know how you can find it. P value is this, PO value is given to you. Everyone, please try to answer this question real quick. Real quick, please. So here, I think for the water droplet, let me call this A so that we don't get confused when we see the notes, right? So water droplet, it is how much? 4 sigma by D, right? So outside pressure, inside pressure is going to be 100 plus, how much is this? 4 sigma. Sigma is 0.05 D. D is how much? D is given to us as 0.05, but it is in mm. I'll convert this in meter. So minus 3. Just check how much the inside pressure. How much? 96 and 108. Is it? Is it 96 and 108? Please check once. And this is going to be Pi equals to 100 plus 8 into 0.05. Okay, both are same only. 0.05 10 raised to the power minus 3. Please, sir, try to answer. I think this is very easy to answer. It is written over there only. Please answer, guys. This is very easy. In front of you, why you are using calculator? You can do this by your own also. No need to use the calculator. How much? 104 and 108. All right. Others? How much you are getting? (104) and 108. So water droplet is 108. Do I have any 108? I don't see any 108. I see 105. And no, it is 104, right? 104 is not there. 105 is there. And so bubble is 108. So I think B and D are the close option, but not the right option, right? So this is something where I think because this is MSQ, there is no negative marking. Your answer is also not matching. So instead of leaving it, just please mark the answer as B and option D, right? But I would say this is not the appropriate option. They should have given the exact answer, because this is not where we are doing the approximation or anything like that, right? So obviously MSQ, no negative marking. You can still attempt the closest answer. Moving on to the next question. Beautiful question it is. A water tank having width of 9 meter and height of 7 meter. Tank having a quarter circle panel at the bottom as shown in the figure. Take density of the water as 1000 kg per meter cube. Which of the following statement is or are correct? Number 1, horizontal component of the hydrostatic force. Guys, I think this is something that you need to know. As soon as you see the question, you should get the answer for this particular one thing, horizontal component, right? You know that horizontal component, which is FH bar, is super easy to find. Rho g h bar A, right? Find out the value here. Rho, you know, right? This is water only, so 1000. Just check with the G. What is the value of G I need to consider? Not given. 9.8 I will take. 9.8. Now guys, tell me the value of H bar. Final answer I will tell you. Just tell me the value of H bar. Please share the value of H bar in this question, guys. What is the value of H bar? Sir, H bar will be 5 and 2 by 2, which is 1. So 5 plus 1. I think H bar is the value as 6. 6. And what about the area? This is the projected area. Projected area is how much? 2. This is 2. And how much is that width here? 9 meter. So projected area will be 2 into 9. So from here, you will get the answer of the horizontal component, and that is, let me tell you, 9.81, and it should be 1059.48. Don't worry about the calculation. I'll do that for you. I need to tell you the concept here. Vertical component of the hydrostatic force is 958.688. Now, how to find out the vertical component in such case in the curved body? So, vertical component is again another super easy thing to find out, and that is rho g v. right? Again here density is 1000, G is 9.81, and volume I need to consider this. This volume I want. Can I find out this volume? Yes, I can find out. How I can find out? If I can find out this entire volume, right, minus the volume of this particular quarter circle, I can do it. So how much is going to be this volume, everybody? Tell me. Can I say 2 into 7? 2 into 7 minus, this is the quarter circle. So how much the area of the quarter circle? Pi r square is the entire circle. So pi by 4 r square. Right? I have got this much, but I need volume. So I'll multiply the width also. Width is how much? 9 meter. So this is the volume which I need to take. Just put the values here. 2 into 7 minus pi by 4. Radius is how much, guys? Radius is given to me as 2 meter. Put the value into 9. So this answer you should get as 958.688. Right? Now you have the horizontal and you have the vertical component. All you need to do is the resultant. How to find out the resultant? FH square plus FV square. Put the values. How much it is? 1059.48 square plus 958.688 square under root. The resultant force that you should get is 142.83. Sorry, not 142. Let me see if this matches. Resultant force is not matching. These two are matching, obviously, A, B. And resultant force is not matching. Inclination, can you get the value of inclination, everybody? Thank you, Alok. Very good, very good. You are very fast with the calculation. Very impressive. Now, can we get the value of the inclination, everyone? Yes, we can. Super easy again. How to get it? I'll do it here only. No need to go on that slide. So, can you please quickly get me the value of theta? Tan theta. This you can tell me, everyone. Theta is equals to tan inverse of vertical by horizontal force. So this will be how much? You are going to tell me in the comment box. Vertical force is 958.688. Horizontal is this much. Let me quickly tell me the value of theta. Is it how much? 42.14. So obviously A and B are the right options here, right? A and B are the right option. If this is not matching, no problem. A and B is the right answer. Moving on to the next question, everyone. Quickly, please tell me, guys, are you enjoying the session? Are you learning something new from this class? Are you able to revise the concept with this session? Quickly, please tell me. And if that is happening, you can quickly hit the like button. Quickly. Full speed. Yes, Arun. Thanks. I am not writing the answer. You find out if it is matching, then option A, B, C will be right. If not, then A, B. हाँ भाई ठीक है, like everything is okay. Like I'm taking session in English after I think almost 2 years. So am I speaking like fine English, or is there anything that I can improve in the English which I am speaking? Like, can you understand? Because everyone is, C is also right. Okay guys, so C is also right here. If one student is saying, just solve this and you will get the answer. So because I am speaking English after 2 years on YouTube, right? So you can tell me if you can understand, because doesn't matter how good English or how good I am going to communicate. The matter is going to be the actual matter, or the, you can say, the most important thing that is going to be is am I able to convey what I'm trying to tell you here with this session? If I am able to convey, you can tell me. If not, then we can see what we can do. Next question is here in front of you. Super easy question. And let's see who is going to give me the very first answer. Please, total mock test 34.3, how to improve, sir. That I think you know better, because you should understand what is the problem that you are having in the test. Please first check that. What is the problem? Is it conceptual mistake you are making, silly mistake you are making, not reading the question properly, or what is happening? भूल गए थे कि इंग्लिश में पढ़ा नहीं ऐसा कुछ नहीं है. पहलवानी जरूर छोड़ दी पर लड़ना नहीं भूले. तो इंग्लिश में सेशन लेना भले ही भूल गए, पर इंग्लिश आती है. हाँ जी सर. So which of the following statement are correct about the laminar flow in circular pipe? Velocity distribution is parabolic over the section. Yes, obviously correct or not? Quickly tell me. Yeah. Velocity is obviously going to be parabolic. Shear stress distribution is linear over the section. Correct क्या? Is it linear? Shear stress or the variation is not linear. Who will tell me? Is there anything that have changed? Yeah, it is correct, right? Pressure gradient is constant over the section. All right. Maximum velocity is 1.5 times the average velocity. Is it correct or not? Maximum velocity is 1.5 times of the average velocity. If it is not, then what is the value that I should put over here? Maximum velocity is 1.5 times the average velocity. If not 1.5, then what? Very good. It is twice of it. Okay. All right. Moving on. Let me just write down the answer also. A, B, and C. Cool. All right, guys. Next question. Oh my God, what a beautiful question I have for you. Please answer. I'm unable to attempt a question, more than 30 questions, but also how to study and improve. That is the thing that I'm trying to tell you. See which subject question you are not able to attempt. Prepare that first. You will be able to attempt more questions then. Water is flowing in a horizontal, frictionless, rectangular channel. A smooth hump is built on the channel floor at a section and its height is gradually increased to reach choked condition in the channel. The depth of water at this section is Y2 and at its upstream section is Y1. The correct statement for choked and unchoked condition in the channel is going to be what? Please answer. For subcritical and for the supercritical. Bataiye sir. What is going to happen? What is going to happen? Everyone try to answer. Till then I'll just draw something. Like I want to draw, so I'm drawing. Okay. All right. Slight, like there is small mistake in this diagram, but okay, please rectify. I don't problem. ठीक है चलेगा इतना क्या? This is the minimum energy. A minimum. Here it is subcritical. Here it is supercritical, right? So see what will happen quickly. Question number 10. Option A is saying in choked condition, in Y1 decreases if the flow is supercritical and increases if the flow is subcritical. Okay, we'll do this here to understand better, right? Let's first talk about the subcritical part. Beautiful diagram. Here we have Y1 the upstream depth, and y2 the downstream depth. Here we have delta z, the height of the hump. Let's say this is the maximum height of the hump. Let's say delta zm. Let's try to understand how everything works over here. Now, till y1, like till this delta zm part, what happens is the upstream depth remain same. There is no change in it, right? Upstream depth will remain same. So y1 is like this. This is y1. This is y1. But y2, what will happen to y2 if it is subcritical? If I keep increasing the height of the hump, can anyone tell me what is going to happen with the downstream depth? It will start decreasing. Yes, it will start decreasing, right, sir? So it will start decreasing. This is y2. But after this delta zm, or you can say here the choking condition has occurred. Now the y2 depth is now become the critical depth. It will not change. Now obviously you can't go beyond that, right? You are at minimum energy. No change in the y2 depth. But y1 depth, now it will start increasing. Everyone, did you got this? Please tell me by sending a heart sign. Is this illustration clearly visible and understandable by you? Is this clearly understandable by you? You can please tell me. If you are not getting it, then I'll try to tell you in other way. But I think this is the simplest way in which you can get this. This is for the subcritical, all right? This is for the subcritical. Right? You can see this here as well. In subcritical, what will happen? If I tell you here, if you keep on decreasing the depth, depth will come here, 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 but eventually it will become here, which is the critical depth. Now, after critical depth, depth cannot go beyond this because then it will become supercritical, right? I can't go beyond this. So what will happen? My depth will start increasing. The upstream depth will start increasing. So in choked condition, y1 decreases. Upstream depth basically decreases if the flow is supercritical, all right, and increases if the flow is subcritical. So I think this is right. This is something which I have also told you right now. In choked condition, y2 is equal to critical depth if flow is supercritical or subcritical. Is it correct? I think yes only, right? y2 always become equal to critical. Like, let me just give you the illustration for the other also, the other thing, that is my supercritical flow. y2 leave it. It will feel bad. y1, y2, delta z, delta zm. So what is going to happen? y1 remains same, no change till delta zm. But the depth of the y2 will keep on increasing up to the level where it reaches to critical depth, like this, increasing, 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 and then it become critical. When it become critical, no change, but y1 will start decreasing. So this is what it will like. It will be like, right? So let me just tell you the correct option here. In unchoked condition, y1 remain unaffected when the flow is supercritical and subcritical. That is also true, right, sir? In choked condition, y1 increases if the flow is supercritical. I think just now we have seen in choked condition, y1 decreases, right? So option D is wrong. So A, B, C are definitely correct. Guys, am I clear? Is there anyone who have doubt here? Please let me know in the comment box right away. All right, I have another question for you. Before that, let me tell you one more thing, and this is also about a free series, but this is on application, BYJU'S Exam Prep application. So we are launching 2 new series. One is for 2024 aspirants, one is for 2023 aspirants. This is a new series on GATE, completely free. All right. So GATE 2024 classes that you are going to get, it is going to be on Thursday, Friday, and on Saturday you will be getting maths and aptitude classes, right? Here in the fundamental series, 10 fundamental concept of the subject of the particular branch are going to be taught by the faculty member. And rank booster is for 23 aspirant. Class will be on Monday, Tuesday, Wednesday. And here 3 most weighted subjects are going to be revised by the faculty member. But everything this is completely free, but not on YouTube. It is on BYJU'S Exam Prep application. If you are interested, you can download it if you are not having it now, right? And you can join this class. Also, you can join this with the website also. Next question. Select the correct feature. I think one more question we will do, and then we'll close the session, right? I think that is enough. 50 minutes are already there, right? Select the correct feature of the flow profile. S3 profile occur on a break in grade from steeper to steep beta. This I think I have taken a session also day before yesterday, I think, right? Steeper to steep. Steeper to steep. Control section. Obviously, this is the steep slope basically. So yn is going to be less than yc. So you can say here critical, let's say this is critical depth, which remain constant, doesn't matter what the flow is, it depends on discharge only. Steeper the slope, lesser the normal depth. So this is your CDL, this is your NDL. So you have to go NDL to NDL. So NDL to NDL you have to go. But also you know that you can't go upward in second zone, right? In zone 1 and zone 3 you can rise. Zone 2 you have to fall. NDL to NDL I have to go. If I try to go like this, doesn't happen. Why it doesn't happen? Because in zone 2 I am rising, which is not possible. So other way is this. Is this possible? I think this is possible. Why? Because this is zone 3. Zone 3 you can rise, and the slope profile name is going to be S because this is steep slope, and 3 because this is in the zone 3. So option A is right. Option 2. S1 profile occur at the break in grade from mild slope to steep slope. Mild to steep to mild, right? Is it? Mild to steep, right? Okay. Mild to steep. Let's see what's mild to steep. Let's say mild is this, and let's say steep is this. Control section. Right, sir? Let's say this is CDL. Critical depth line. Critical depth line. And then let's say, because guys understand, this is your mild section, right? Mild. This is mild, this is steep. Mild is basically when the normal depth is above the CDL. So NDL. But in here, steep, it will be here. Now again, NDL to NDL we have to go. Can I go like this? If I try to go like this, is it possible? It is not possible because in zone 2 you are falling, it's okay. But here you can't. जंप करेगा सर और फर्स्ट ऑप्शन में, फर्स्ट ऑप्शन है, मैं अभी आता हूँ उस पर ना, एक बार ये देख लो. देखो जोन 3 है, जोन 3 में फॉल हो रहा है, नॉट पॉसिबल. ठीक है, तो ये तो पॉसिबल ही नहीं है, तो इसको हटा देते हैं. और क्या पॉसिबल है? क्या ऐसा चले क्या? जोन 1 में फॉल हो रहा है, सॉरी व्हाई आई एम स्पीकिंग इन हिंदी, आई एम रियली सॉरी. इन जोन 1 you are having fall, right? So obviously not possible. I hope I have not spoken English for too long. Hindi, sorry. So what is the other option? Other option is this. If you go like this, here also fall, here also fall. Yes or no? Quickly, please tell me. Yes or no? Please tell me. So the right answer should be, this is what? M2 and S2. Right answer is M2 and S2. What they have said in the option S1. Oh, definitely it is wrong. Right. Next is M2 profile. M2 profile occurs due to sudden drop in the bed of mild slope channel and at canal outlet pool of water. Answer. Let me talk about this. Okay, so someone was saying hydraulic jump. See, hydraulic jump cannot be there until unless you are going from super to subcritical, right? We are not going from super to sub. This is also your supercritical. This is also your supercritical, right? So you are not, if you go from steep to mild, steep is a supercritical and mild is your subcritical. That time you will have the slope by having M3 as the predecessor. I hope I'm correct, like clear with my words. Okay, this is also true over here, right? S1 profile is always preceded by the hydraulic jump. S1 profile is always preceded by the hydraulic jump. Quickly answer. Please answer. S1 profile is always preceded by the hydraulic jump. Is it? Remember one thing, that hydraulic jump will follow, not always, but like one of the, like, it is possible, it is possible. S1 profile is always preceded by hydraulic jump. It is possible, correct? But there is one thing, that there is this M3, H3, A3, M3, H3, A3. After this, you will have hydraulic jump, correct? Only possible way, because you go from the third zone only, right? So yeah, this is not always, but yeah, it actually proceeds by this. So I'll say D is also the right answer over here. So the right answer for this particular question is A, C and D. I think someone has given this answer way before. I think Alok. No, Achu has given it. Okay. Moving on, last question. What is the depth of the flow in a circular channel of diameter 2 meter for the maximum velocity, all right, and the maximum discharge? So what should be the depth of the flow in a circular channel? This is something you have studied from open channel flow, I suppose. So you can answer this. Come on. Maximum velocity can be achieved by 0.81 d, right? And maximum what? I think discharge they are saying, right? That's 0.93 d for circular. For the values, 0.81 times of what? 2. Directly get the answer, 1.62. And YD, 0.93 times of 2, जो भी remaining बचा, 1.86 I suppose. So these two options are correct over here, right? Option C and option D. And that actually summarizes our session. So I hope you guys have enjoyed the class and you have learned something new from my session. Now I'll see you in the next class. Till then, please take care of yourself. There is one more thing, one more announcement that I have to make. Tonight at 12 a.m. or you can say precisely at 11:59 p.m. You are having a session of aptitude in which 20 most expected questions of aptitude for GATE examination we are going to give you, but not just normally. We will give you this in form of a Menti war, and this Minty war, or you can say the Minty competition, will be between two teams. One team is RCB. RCB is Rakesh K Challengers and Blasters basically. So this is the team of Rakesh Talreja sir, as you all know him, right? And the other team will be mine, that is Ninja K Night Riders, that is NKR. So this is basically between me and Rakesh sir. Tonight at 11:59 or precisely you can say 12 a.m. you have to be there. I hope you all are ready for this particular session tonight at 11:59. So if you guys have enjoyed it, how much is it? 0.9 precisely I have written 0.93. You can see option, you can directly match, right? So I hope you all have enjoyed today's session, and I actually really enjoyed it because after 2 years I've got the opportunity to take the session in English. This is tough, but I really enjoyed it. I really enjoy tough things. Thank you so much for being here, everyone. Thank you so much for joining this session. Now, I will see you in the next class. Till then, you have to do two things for me. Please take care of yourself, number one. And number two, please take care of your family. Thank you so much for being here. My name is Joshit Singh. And now, I will see you in the next session. Bye-bye. Have a nice night or enjoy the life, right? Just please hit the like button, share the video and subscribe the channel if you are watching me here for the first time, because I am going to come up with lot more videos like this. Thank you so much. Have a nice time. Bye-bye. Good night.